Hey, fellow mathers, before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
I'll tell you what, Pam, it's the 100th episode, right? We're super excited. And since it's the 100th episode, we thought we would celebrate our base 10 system.
Right? Why not? Yeah, let's bring it on. Let's talk about 10.
Fun
10
fact,
squared.
my kid is 10, right?
Okay.
Yeah.
All right.
And my grandmother is about to be 100.
No.
Yeah. Is that amazing?
Seriously?
Yeah, for real.
Wow.
It's pretty cool.
Okay, so I'll just join right in there, a claim to fame. I'm half of your grandma-ish. I'm in my 50s, and maybe won't tell you which 50 I am, but I'm in my 50s, so
yeah.
There you go, for like 5 10s. We're talking about 10 today, 100, 10 squared. Yeah, so lots of nice.
Yeah.
Oh, I can't believe your grandma's almost 100.
I know. It's amazing.
Wow. Nicely done, Grandma. Woo. Mm-hmm. So we thought, as we talk about our base 10 system today, that we would emphasize something that we find really interesting to talk with teachers about, work with teachers, work with students, especially because often we might be talking past each other just a little bit. We might not know exactly what we mean. So we're going to dive in today. When I was very first doing early professional learning with elementary teachers, I had been doing professional learning stuff with secondary teachers for a while, graphing calculators, how to make higher math visible. But when I began doing that early professional learning work with teachers, teachers asked me, hey, Pam, one of the things we need to do, we need to talk about place value, like our kids' place value. And I kind of dove in, and the more that I saw what was happening, the more that I when I talked to teachers and I understood what they were doing in class, I got really clear. The teachers were spending an awful lot of time on what I would call place labeling work, and not really place value work. Because teachers were asking me, Pam, come help us with place value. Okay, tell me what you need. And then I would see these 6-week units on place value. I just put quotes, air quotes, place value in quotes.
Yeah.
And I would like, when's the place value work going to start? And they're like, well, like right here. And I'm like, you're having them label the places. Okay, good. That's necessary. Like they need to know the name of the places. They need to be able to like sort of write the number in expanded notation. All that's necessary, but it is not sufficient for kids to really understand and deal with and own place value. Yeah?
Right. Absolutely. I remember my very first teaching job was 3rd grade. And I remember being handed binders like, hey, this is what we do. And you're not joking. 6 weeks. The first 6 weeks was very much about place value. And it was all intended
Wait, are you quoting that? Is it place?
Oh, I'm air quoting. Sorry, air quoting. Sorry, you can't see me. Yeah, absolutely. Because the idea was first we get kids good at place value and then they can actually do things with it. And so I remember feeling really awkward about that and like just kind of going along with it. And I think you probably stumbled into that conversation on my campus as well.
Yeah, absolutely. Yeah. Well-meaning teachers, right? I mean, you guys were doing your best. There was this, like you said, it was all set up. You dive in, you're doing the
Yeah,
thing. And then I would hear the frustration in teachers as they would
sure.
discuss students' complete lack of reasonableness.
Yeah.
Like the kids wouldn't estimate. They would, and they would get to the end of a problem, and the answer was so completely out of the ballpark. So of
Hmm.
course teachers were frustrated, and they could. Y'all had a sense that there was a lack of place value, a lack
Hmm.
of understanding that the value of the number depends on the place the digits in.
Right.
And that real sense of value was missing, and you guys had a sense of that. Y'all had a sense of that it was missing, but you knew you'd spend all this time on it, like
Oh,
all
yeah.
this time and effort, and so you wanted to see more bang for your buck, and you were really interested in what were some things you were missing, or some little tips and tricks that you could to make those place labeling units better. And my answer was stop doing all that. Like
Yeah.
we're in a huge way, we are treading water here. We're sort of wasting time. Kids that can do it, and don't really get a lot out of it. And kids that can't do it, can't do it. It's like a lot of memory work and everything, and we're not really developing value. So Kim, what are some of our favorite ways to actually develop place value with students so that they really understand the magnitude, the sense of size of numbers, and how all of that depends on which place they're in, what place that digit is in, those digits in that number, because we have this super, super cool place value system.
So one of my very favorite activities or routines is a count around by
Yeah, nice,
tens.
nice.
Yeah. So if you're not familiar with count arounds, people have different images of what that might look like. But for me, a count around is where we start with a number. Sometimes I'll ask my students what number you want to start with. Sometimes I have a predetermined number. But let's say I'm starting with second or third graders, and I might say, give me a digit between or a number between 1 and 9. And so a kid might say 7. And so I say, okay, so we're going to start with 7 and we're going to count by tens. And so I will record as we count. I'm going to record the numbers. I'm kind of doing this with my hands, but vertically, where each number is recorded one beneath the next so that the place values line up. And so somebody might say 7, and then the next person might say 17,
And you just wrote that
27.
below. So you have
Right.
7, and then below that you have 17, and then below that you have
27,
27.
37, 47. And we'll go around. And then the most important part of that is to step back and take a look and say, what do you notice? Like, what patterns do you notice? What do you see? And so that conversation is bringing out the place value-ness, the things like I notice that all the ones place continues to be 7 and 7 and 7 and 7 and 7. And so we'll have a conversation about why is that? If I start with 7, why does every subsequent 10 that I add on still going to end in 7? What would
Yeah.
happen if I started with 9? What would those numbers end in? Also, very early, I found that students were able to pick out the 110, 210s, 310s, 410s. And then as you get further down the line, they notice 910s, 1010s, 1110s, 1210s. And I remember that being one of the most difficult conversations to have with kids when I was just doing place labeling work, because we would have to say things like, in the number 123, how many tens? And you know what kids would always say was 2 10s. There was only 2 10s.
123. There's only two tens.
Mm-hmm.
Yeah, total
Mm-hmm.
of two tens.
There was no way.
Kim, that's correct. In the number 123, there are only two tens, right?
Not only.
Well, it sort of depends. It
Yeah.
depends on if you've already stripped out the 100.
Right.
If you've already stripped out those 10 tens, then how many
Yeah.
tens are left over? Okay, there's
Yeah.
just two, or there's two tens in the 10 slot. Can I say it that way?
Yeah.
But only if you've already stripped out that 100, those 10 tens. So if
Yeah.
you a total number of tens in 123, that has to be 12. There's 12 tens.
Yeah. Absolutely. And I just remember that being such a difficult conversation because I didn't have an experience at that time to give them so that they could really feel the 1210-ness of the number 123. So count-arounds are one of my favorites for a
Well, and
variety of ages.
I feel like one of the things I want to emphasize is the fact that you were recording
Yes.
those values on the board. And you
Yep.
made a really specific point to say that you were recording them vertically, but that's not always true, right? It depends on how you're counting around and the
Yeah.
pattern that you want to bring out that
Sure.
day.
Sure. It just depends on the pattern that we want to bring out. But I feel like because we're talking about the base 10 system, that's the one that I happen to
Right.
mention.
Right.
But yeah. And so
Can I give an example of another one just really
sure.
fast?
Yeah.
So I did a lot of count arounds with a group of second and third grade teachers a few weeks ago, and one of the ones that we did was we counted by twos. And I don't even remember what number we started with, but we just literally wrote, maybe we started at 0, even 2, 4, 6, 8, 10, and I wrote those horizontally. So
Mm-hmm.
0, 2, 4, 6, 8, 10, and then I wrapped around, and then underneath each of those, oh,
Yep.
sorry, I wrote the 10 under 0, and then 12 was under 2, and then
Uh-huh.
14 was under
Nice.
4, and then I said, hey, and before I could say much, one of the teachers was like, that pattern we just looked at is happening again. And I was like, where? And she said, over there in the tens, look, there's 10, 20, 30. We're seeing the tens count up again, and the zeros staying this. It was like the patterns that you just kind of talked about, the number of tens. And this was an adult, like,
Right.
hey, look, it's happening again. Different patterns can come out. If you're counting by fives, there's a fun reason to go 0, 5, and then wrap back around 10, 15, and then wrap back around 20, 20. But lots of different ways that you can kind of wrap around vertically, horizontally, where different patterns can come out. And because it's our base 10 play system, base 10 patterns are going to pop.
Right.
That's going to be one of the things that's going to happen. All right, sorry to interrupt.
It's just an added layer. The recording and pattern noticing is an added layer that's the most important part to add on to what people are kind of sing song counting 10, 20, 30, 40. Yeah, love it.
And then also notice that I started with 0 in the several counts I just did, but then you don't only want to do that. Like sometimes you want to count by twos, but you want to start with the number 7 and count by
Mm-hmm.
twos. You want to
Mm-hmm.
start with 13 and count by twos. Or a lot of kids can count by tens, but only from 0, 10, 20, like you just
Right.
sing song. But starting with 7 and then counting tens, or starting with 8 and then adding 10, whole different game. And then I have to mention one of the favorite things I've ever seen you do is then count by nines. So start with a
Mm-hmm.
different number and count by
Mm-hmm.
nines. And can you talk a little bit about how that pattern pops out?
Yeah, so it's especially fun when I'm working with adults. Adults are interesting learners because they maybe have a little bit of a different worry than kids do. And so it's so interesting to me. But anyway, counting by nines, the pattern that can come out really nicely is that 9 is made up of a positive 10 and a negative 1. So a lot of times when I'm counting by nines, somebody will say, well, I added 10 and then I took away 1. So 9 to get from 9, or maybe let me start with 7 again. So 7, if you're adding 9, you can add 10 and then back up 1 to get
Nice.
to 16. And then you can add another 10 and back up 1 to get
So I could
to,
think 16, 26, 25.
yeah. And what I found interesting is that sometimes people will do the backup 1 and then add the 10.
Ah,
So it's like two different ways of thinking about it, but still plus 10 minus 1 or minus 1 plus 10 still is equivalent to 9. So that's a
yeah,
nice
brilliant.
conversation that comes out with, it can come out with both kids and adults.
And sometimes adults will have this funny, or even kids will have this funny kind of a trick or rule or something. They're like, oh, yeah, adding nines, it's one less.
Mm-hmm.
And they'll kind of have this sense like they've done it a lot, but getting them to verbalize what you just said can be really powerful and kind of
Mm-hmm.
abstract. That generalization can
Mm-hmm.
be a powerful thing to do. Yeah.
Yeah.
What about the tens pattern that happens when you're counting by nines? Can we do that in a podcast?
I don't know what you mean.
So like a lot of when you teachers will follow that pattern that you say, where they'll add 10 and then back up 1. And so as we're going along, if I were to record 17, 7, 16, and then 25, and then 34, and then what, 40, help me,
42,
3, and then
43.
so sometimes the teachers, as they're going, so say we're at 43, they'll just start realizing that if they look back at the numbers, so y'all, if you're listening to the podcast, you might want to write these down: 7, 16, 25, 34, 43. then they'll start realizing, oh, look, the tens are just counting up by one.
Oh, yeah, yeah, yeah. And the ones are going down by one, right?
Yeah, because so if I look at the tens right now, I had 16, so that's one ten, and then 25, two tens, 34, three tens. So one, two, three, four. But
Yeah.
the one, like you said, the ones are counting down six, five, or seven. We started with seven, six, five, four, three. So then they'll go, oh, the next one's going to have to be count up by one, five, 50, and then count down 52. And then the next one should be count up 61, and the next one should be 70, 70.
Uh-huh.
And then they stare. Then they look at it.
Yes.
They're like, okay,
That's the
so
best.
let's see. It's
Yeah.
got seven's got to go up to eight, so 80, and then they look at that zero because they were
Mhm.
at 70. And look at the
Mhm.
zero, and then they look back at the ones, and it's counting down. They're like seven, six, five, four, three, two, one, zero. What in the world? What
Yeah.
happens
Yep.
next? Like ah, and then someone in the group will snicker a little bit and go, what's the next one? 70 and nine more. 70 and nine because we were at 70, nine more.
Mhm.
But if they're stuck in that, so it's just 79, right? It's not 80. Like the tens don't count up in that case. And
Yeah.
so the pattern kind of breaks
Yes.
between 70 and 79.
And you can tell in that moment that they've found a pattern that's new and interesting to them. And they're so focused on the pattern that they stop really considering the amount. They stop considering the value. And so
Mm-hmm.
it's a really nice opportunity to pause and have a conversation about like patterns are cool, but you can't stop thinking about what's happening with number as well.
Bam! Never stop thinking. Never, never, never stop thinking. Yeah, so that's like one of my favorite things that can come out. And then I have seen you masterfully then count around by 100. So adding 100 to something, starting with like the
Mm.
number 34 and add 100. And then after they look at place value patterns and they watch the sort of tens, now we can talk about the number of hundreds and the number of tens, and that's a whole big deal, right?
Uh-huh,
Um,
yeah.
and and then you'll say, okay, super job, everybody. Now let's count by 99.
99.
I've also seen you do count back by 10, count back by 9,
Yeah.
count back by 100, count back by 99, and super fun, wonderful place value patterns can come out. Totally agree that count arounds are wonderful, a wonderful, super good way to develop place value with students. Do
Right.
you want to add anything else about count arounds?
I think we have a recording actually, right? On your website in case people
Oh
want to see
yeah,
that.
yeah. So we have a section in the website. If you go to mathisforgettable.com and click on Learn Now,
Yeah.
then you'll see instructional routines. And in instructional routines, we talk about countarounds. There's a couple of videos that you can watch. We talk all about how to do countarounds. The fabulous, nicely. I forgot we had that. Yeah, nice.
I think it's still there.
So this reminds me of another thing that I saw pretty early in our work together because we were using investigations in data, number, and space
Yes.
when we first started working together. And one of the things that they did in there was a thing called multiple towers.
Yeah.
And I thought it was a brilliant way to get kids to start to notice lots of things, but one of which, well, let me tell you about multiple towers, and I'll tell you one of the things that I thought came out that was nice. The idea was to have at least this is the way I remember it, but you'd have students in maybe pairs or threes. I think it was pairs, and you would give students different starting numbers and different, well, I guess different multiples, not starting numbers. So, like, I might give you, well, Kim, I might give you 27s, and I might give a different group sixes, and I might give a different group 12s, and I might give a different group 25s. And then you would literally create what they call the multiple tower. So if you had 25, you would start with zero, and then 125, and then 250, 375, and 4, 100, and so on. And so you kind of would create, in a sense, an in out table. And it was actually a ratio table, it was a baby ratio table, where it was every single multiple was listed, but
Mhm.
not just every single multiple, because next to it, you would also record how many of that number there were. So I
Mhm.
could look at 425s, or I could look at the 4, and next to it would be 100. So brilliantly, and they had kids put these on strips and stick them all on the wall. And so
Yeah.
you could look on the wall all around the room. And again, some of the students were counting by 13s and some of the students were counting by 27s. But as you looked around the room, you could notice the 10
Mhm.
and notice that the kid who had 13, 10 of them was 130. And the kid that had 27, 10 of them was 270. And the kid that had, now pick another one, random, 15. The kid
Mhm.
that had 15 had 149. And then you're like,
Yeah.
and then there could be some conversation about, like, is there, do you think, should it follow the pattern? Like, do you think,
I almost
it,
feel like we collected data about the 10th count. Maybe I'm remembering incorrectly, but I almost feel like we said, "Hey, you guys, what did you get for the 10th one of yours? And what did you get for the
mhm.
10th one of yours?" And we collected that information to make on a chart as well.
Absolutely. And so all these wonderful ways of getting now, so there's other neat patterns that can come from that, but since we're focused on our base 10 play system today, that idea of what the 10th count was, and whoa, like all every time 10 threes was 30, and 10 13s was 130, and 10 17s was 170, 10 25s was 250, and that zero pattern, we could bring it out sooner maybe than kids kind of stumble on it on their own. Like everybody's kind of stumbled on that pattern that when you multiply by 10, there's sort of this place value shift where there's that zero at the end that kind of represents the number of ones left over when you multiply by 10. Everybody stumbles on that pattern. But we don't maybe necessarily do it on purpose. Well, let's
Right.
do it on purpose sooner.
Yeah.
Like, let's put it up in front of kids and get them thinking about why it was always the 10th one and what's happening when we have 10, say 13s. Does that have anything to do with 13 tens?
Mm.
And if we have 13 tens, is that another way of thinking about 130? And again, we needed to have a little bit of place labeling happening so we can sort of talk about what 13 tens would look like if I sort of put 13 in the tens slot. Oh, yeah, 13, or if I counted by 10, that's a little easier sometimes for kids to feel 10, 20, 30, 40. What would it be if I get up to 13 of them? Well, yeah, it'd be 130 because 10 of them was 100, 10 tens was 100. So 11 tens would be 110, 12 tens would be 120. They could kind of feel those tens. And so by using the commutative property, we can get students to start thinking about those 10 13s as 13 tens, or those 10 27s as 27 tens, and just making more and more sense of our place value system. And we thought that multiple towers was a great way to do that.
Can we take just a little bit of time to talk about everyone's favorite, or maybe not favorite, uh, base 10 blocks?
Yeah, because obviously, I mean, Kim, we should have mentioned those first. They are the be and end all, right? Like
That's
if
how
we
you start,
really
right?
want to teach kids place value, we should have placed 10 blocks from like in the cradle. Like kids should
Mm,
have them. They should be the things
mm,
they play, because if kids play with those early, they will understand our place value system. Like hands, like no prop. Why didn't we mention those first, Kim?
mm.
So we're joking a little bit here. We're poking fun just a little bit. Um, Base 10 materials are a little tricky. There's a subtle thing happening in that often as adults we have done some work, whether it be to understand the algorithms, whether it be to look at patterns like we just talked about, and we start to get a sense of what it means to have 10 ones and call that a 10, and to
Mhm.
have 10 tens together and call that a 100. And so when we see base 10 materials, we can almost like recognize kind of some of the patterns that we've kind of built, especially if somebody kind of helps us work with those base 10 materials. We can kind of go, oh wow, look at those patterns that I've kind of been fussing around with in my brain a little bit, and now I can kind of like touch them and feel them, and ooh, I bet if we handed these to kids, we could bypass that step of
Right.
having them have to notice patterns and fuss with them and
Mhm.
struggle with them a little bit to make sense of them. I bet we could bypass that step and just kind of unzip their heads and pour base 10 materials in, and bam, they're just going to understand. They'll just like get a feel for,
It's so
and
nicely
what,
organized, right?
it's
Like,
just so
you
nicely
know?
organized. It's right there in front of you. It's so clear.
Mhm.
Like you should just be able to clearly pick it up.
Mhm.
And we're suggesting that that's not how learning occurs. Learning doesn't occur as we, and Kathy Fosno said that we're pretending that the manipulative embodies the mathematics. We're pretending that the mathematics is so like it's so, what's the word, transparently there that kids just should be able to just bam pick it up. And it's not what happens. In fact, a lot of teachers have to have some experience and mess around with even those base 10 materials before it makes sense. Another pushback that I have on base 10 materials is too often I see them used solely and only, or for the main purpose of helping students understand the steps of a traditional algorithm. We're trying to get kids to understand why we're regrouping, why we're borrowing or carrying, what's happening. And so we represent the numbers, and then we pull all the tens to all the ones together. And hey, look, we have more than 10, so we can exchange these 10 for a 10. Oh, look, now we have a bunch of tens, and we can count those. Oh, look, we have enough tens that we can exchange 10 of those for 100. And oh, now we can count the number of hundreds, count the number of tens, count the number of ones.
Mm-hmm.
And oh, we kind of understand now that carry. Oh, it's like we carried that one over there. It's kind of like we carried that 10 over there. And I would submit that maybe one of the reasons why teachers are so enamored with base 10 materials is because it might be the first time you understood the traditional algorithm. Oh, that's what that little one is. That's what it means when we cross out that 3 and make it a 13, or we cross out that 9 and make it an 8, so that we can then make that 3 over there a 13. That's what, like, we're actually like, you could, oh, that's what's happening. That's brilliant if your goal is to understand the traditional algorithm. Not our goal. And if you don't remember that, check back a few previous episodes where we talked all about the different algorithms and what our goals actually are. I should say all the algorithms. We talked about the operations and the strategies that are our goals for those operations. And it's not really to build the traditional algorithm, to build understanding of that. Do we want the place value understanding in the traditional algorithms? Yes, but we don't need the algorithms to do that.
Right. Can I poke on a couple of things? And it's really not even the base 10 materials themselves, right? Like they're objects. So it's a lot of times what we see happen with them, as if doing a couple activities is going to help kids understand. But if that were true, could we stop calling them unit flat rod, or unit rod flat? Can we at least call them the value that they're supposed to represent? So that's one thing. The other
Oh my
thing
gosh,
is
wait, I have to tell you a story.
Yeah.
So early. Like, this is so early that my kid was in second grade. So one of the very first things I ever did was I said, hey, can I just grab some of you, the 2 kids from each of your classrooms, and I'll just enrich them once a week.
Mm-hmm.
One of the weeks I went, the teacher said, oh, sorry, we didn't tell you. We can't actually have you do that today. But hey, would you work with this student? This student needs some help. Would you just help this student? Here are base 10 materials. Help this student understand, I think, how to add with them or something. And I was like, how do you add with what? Like, whatever. So I just sat down and I was like, hey, tell me about these. And this delightful student said, well, this is I don't even know what she called the unit. I don't know what, I don't remember what that was, but she goes, and this is a rod. And I was like, it's a what? And she goes, it's a rod. And I was like, okay, but what is it? And she goes, it's a rod. And I said, well, I know, but like, how many things are, like, there's 10 of them in there, right? And she goes, I don't know.
Mm-hmm.
And I was like, wait, you don't know? And she goes, you think there's 10 in there? I was like, I think there might, let's check that out. So like, we counted, she goes, there's 10. And I was like, okay, what's this thing? And she goes, that's a flat. And I said, how many do you think are in there? I don't know. What do you think? There might be 10 of these rods? Maybe. I mean, it was unreal. So the idea that we that the names could be important. Now, that doesn't mean that if we name them correctly, that it will magically make everything better. No, but certainly it will make it less horrible. I don't know.
I'm not sure. The other thing that I think, and I know we're going long, but the other thing I have to mention is that we will, like 4th grade teachers, right, will use base 10 blocks as 1s, 10s, 100s. Cube might be 1,000 if you have one for your class set. Then we reunitize those because it makes sense to us as adult learners, or maybe to some of our students. We reunitize those when we talk about decimals, and we say, okay, now this is 1, and we're going to call this a 10th and these 100ths.
Yeah.
Without giving kids we just, it's like new unit next day, bam, we've reunitized. And we leave kids going, I don't know what you just did, because for years I've been calling this 1, 10, 100.
Or even worse, 1 rod flat.
Unit flat rod.
Yeah, all that. So while we don't disagree that might be a worthwhile endeavor to do that reunitizing, students will need a lot of experience making sense of what's happening. So we think base 10 materials are fine for building relationships, not as tools for computation. So not in order to add things together, not good. Let's name them correctly, and we can use them to like build relationships, but not in order to add or subtract. It's not about helping kids understand algorithms. Not the best way to do that. Hey, if you're interested to learn about how we would do more to develop place value and you want to dive into teaching real math, then we have deep dive workshops. Y'all, we have created workshops where you can dive deeply into building addition for young learners, building powerful multiplication, building powerful division, building powerful proportional reasoning, and coming soon, building powerful linear functions. And right now, those workshops are open for registration.
Absolutely. You should join us in those workshops. They're available now, right? Open registration now.
Yeah, so at mathisfigureoutable.com/workshops, you can find out all about the deep dive workshops that we've got going on. Registration only opens 3 times a year. We'd love to have you join us. If you want to understand how we would build place value, especially in the content that you're already teaching, save all that time that you've been sort of using and I was about to say wasting up front, in a much more efficient way where kids are actually building place value and not just place labeling, check out mathisfigureoutable.com/workshops. And if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.